Our goal for today is to do a little review. We're going to review graphing and inequalities and naming inequalities from on a number line, and also solving some one-step inequalities using one inverse operation. Let's start with looking at some graphed inequalities. These have already been graphed for us, and we notice that anytime we write an inequality, we always start with our variable. So I'll choose x. X is greater than or equal to 4. In my second one, I see an open circle, and I see the shading to the less than direction. The numbers are getting lower. X is less than -4. There's one more, and in this one I have another open circle which says it's going to be, and it's shading to the right, it's going to be a greater than, and x is greater than 1. Let's move on to the ones where you need to graph the inequality yourself. I have three examples here for you. First thing you do is you read the inequality, x is greater than 2. This tells me there's an open circle at 2 and shading where the numbers get larger or greater in positive infinity. Second example, my number is -1. X is less than or equal to -1. I find -1 on the line. I put a closed circle and I shade everything in the less than direction. And the last one, x is greater than or equal to 0, closed circle, and shading everything in the greater than direction. Remember, the direction of the inequality gives you the hint as to what direction to graph in. Please be careful, because if I do give you something like 3 is less than x, remember that you have to rewrite that as x is greater than 3 before you go ahead and graph. So again, a rough sketch of that one. It would be open circle and shading. Always, always, always write an inequality with your variable first. Now let's look at determining whether a given number is a solution to the inequality. We'll do what we've done before with equations. We'll substitute in the given value. If x were equal to 2, this says that 7 is greater than or equal to -3 times x. I'm replacing x with 2. I then have a statement that says that 7 is greater than or equal to -6, and that's a true statement, so 2 is a solution. Let's use this same inequality, and now let's check -2. 7 is greater than or equal to -3 times -2. Let's do the math, and that gives me 6. Is 7 greater than or equal to 6? Once again, a true statement. -2 is a solution. Using the same inequality for a third time, let's replace x with 0. 7 is greater than or equal to -3 times 0. Is 7 greater than or equal to 0? The answer once again is yes. 0 is a solution. Our final one here says let's take 7. Is 7 greater than or equal to -3 times -3? Well, -3 times -3 is a +9. 7 is greater than or equal to 9. The answer to that is false. -3 is not a solution. So you see that there'll be times when you'll be asked to test out a possible solution to see if it makes a true statement. Now let's spend a little time doing some one-step inequalities. We're going to remember that we do the inverse operation to isolate our variable. In this first one, 5 times x says let's divide by 5. And x is greater than 9. If you remember the end of our last class, we had a list of important things, and here's one of them. Anytime you multiply or divide by a negative, you must reverse the direction of your inequality. Always look at the sign in front of each number. In this next one, I have negative 7 plus x is less than 8. So in order to eliminate it, I must add 7 to both sides. X is less than 15. I see x plus 4. Inverse tells me to subtract. I get 6 is greater than x. But wait, before I tell you that I'm done with this problem, I must reverse the statement, and x is less than 6. Variable always comes first. Let's add 3 on both sides for our next inequality. And I get x is less than or equal to 8, negative 8, that is. I see a negative, and it tells me that I'm dividing by negative 3. When I divide by negative 3, it reverses the direction of my inequality. But once again, I need to write my variable first, so this was a double reverse. It reversed once for the negative, and it reversed a second time to get the variable first. The next problem is a division, so we'll multiply both sides by 4. I get x is greater than 16. Another division, this time by a negative. Remember, when I divide or multiply by a negative, I reverse the direction of my inequality. One last problem. I see 4 times x, so I'll divide by 4. X is less than negative 6. So today we spent some time reviewing. We reviewed by graphing inequalities, writing inequalities, testing out possible solutions, and then actually doing the solving of some one-step inequalities. And that's all we have for today.